My name is Masar Sheikh, and this is my Lab 3 PowerPoint. So the purpose of this lab is to use what we know about loop rule and charge conservation in order to predict the behaviors of circuit and measure the voltage and current, as well as examine the behaviors of resistors and capacitors. For the first part of the experiment, we set up two 1.5 volt batteries, two ammeters, and two resistors. And we had to measure the current in I1 and I2. And since it's a series circuit, the current is uniform and gave us a value of 0.02 amperes. And when we replaced the ampere with the voltmeter for I1, it opened up the circuit, leaving a current of 0 amps, but measured a volt of 3 volts from the two batteries. And when we replaced the 100 ohm resistor and put it parallel to the other resistor, we measured the current as 0.09 amps, as the total is now being added through inverse addition rather than regular addition. And for this part of it, when we measured the voltage across the circuit, we got from point A to B a measurement of 3 volts, and from point C to D a measurement of negative 0.96 volts, and from E to F negative 2.04 volts, making the net potential equal to 0 at the end, which makes sense and follows the loop rule. And dividing these currents and dividing the values that we got by the currents, we get R of 47 ohms to equal exactly 47 ohms, R of 100 ohms to equal 100 ohms, and a resistance of 0 ohms for the wire and the ammeter, as this is a ideal circuit. And for the RC circuit, with the capacitor in the circuit, the light bulb shines but slowly diminishes as the capacitor fully charges. And when the capacitor is full, we could take out the battery and discharge the capacitor, which makes the light bulb have the same reaction of lighting up and then slowly dimming. With a 10 ohm light bulb, it took about 6.5 seconds to charge and 5.5 seconds to discharge. And when we increased the ohms of the light bulb to 20 ohms, it took about 8.3 seconds to charge and 8.8 seconds to discharge. And the reason why the discharge is longer is because of the increased resistance of the light bulb. And for the last part, when we set up the circuit with the charge capacitor, I measured the voltage over a 20-second time period and charted the time as well as the volts. And then with the volts, I took ln dV over V naught, with V naught equaling 9 volts, which is what we started with. And from there, I plotted it in the Excel sheet, and we got a slope of negative 0.165, and the slope is equal to negative 1 over RC. And from that, we could calculate RC as equal to 6.06 ohms farad, which is really close to the true value of 6 ohms farad, which we can measure by the 30 ohms resistance and the 200 millifarads, which is equal to 6. And for the additional questions, what if the experiment were done in a real life manner, a real ammeter would have a non-zero internal resistance, ultimately altering the results. And if we were using a real battery and capacitor, the battery would have taken a slightly longer time to make the capacitor reach full charge, as over time a battery wears out and loses the amount of voltage it has.